All right. Good afternoon, everybody, or good evening, wherever you're from. My name is Brian, and today I'm going to be hosting a workshop on building a blockchain using Starport. And in reality, it's going to take roughly 5 minutes to have a functioning blockchain. So in case you don't know what Starport is one of the tools that Tendermint has built to scaffold blockchain applications really quickly. So if you don't already have this installed, or if you want to just look at the source code really quickly, or look at the repo, it's at github.com/tendermint/starport. So a bit about the application we're going to build. So we're going to be building a proof of file existence blockchain. Now, some of you may be wondering, what is a proof of file existence blockchain, or what is proof of file existence? So proof of file existence is basically taking the hash of a document and being able to prove that you had that file or document at a certain point in time. And so essentially what we have to do is we have to perform a SHA-256 hash on a document or a file, and then upload that hash to the blockchain. So we can assume that the SHA-256 hash of the file, aka a checksum, is going to be unique for each document that you would input. Someone also mentioned that, like, let's say, the chances of finding a collision in a SHA-256 hash is less likely than the chances of us being hit by a meteor in the next second. So if you're worried about SHA-256 hash collisions, then your priorities are not in order. So just going over a bit about the use cases for proof of file existence. So as I mentioned, you can kind of timestamp documents in a way. So when you upload the hash of a file to the blockchain, it validates that you had a certain file that produces this hash at a certain time. So if anyone wants to, let's say you have an invention or something and you save it in a PDF document and you want to prove that you came up with this idea, instead of sharing the document publicly, you can just take the SHA-256 hash of the file, upload the hash, and later on in the future, when you do want to reveal the document, you can just take that transaction hash, prove that you made that transaction, and then share the document. And the person on the other end can just compare the value of the hash that they get from the file you shared with the one that was submitted to the blockchain. So another use case is for just overall document integrity. So let's say a government or any other organization can issue digital forms of legal documents and submit this hash as a proof of file existence. So when one wants to, let's say, use their digital document to, let's say, sign up for something, all you have to do is just compare the hash of the document with the one that was submitted in the blockchain by whatever entity, and then you can validate that it's authentic. So this kind of gives us an overview of like what the use cases for proof of file existence are. All right, so before we get started, we want to have Starport installed, but there is another way of doing this. So you can actually just have a web-based IDE. So if you guys are watching right now, go to github.com/tendermint/starport. You can either install it via npm, or you can just click this link, build a blockchain with Starport in a web-based IDE. And that will take you to Gitpod, and it will create a web environment for you to develop your blockchain. So let's just wait for this to initialize. Great. So now we can see that we have initialized a repository with Starport installed. We have some docs on the side. And if you're familiar with IDEs, you can see that this kind of looks like VS Code. In a way, it's basically VS Code, but inside a web UI. So what we're going to do to start off, we are going to scaffold our application. So what we're going to do, we're going to run starport app github.com/ whatever your GitHub username is. I'll just use mine / proof of file existence, or POFE, whatever you want to name this app. So let's initialize that, and then it will say successfully created Cosmos app, POFE, get started. So let's see, we have the directory created here, cd POFE, and starport serve. And I'll open up another window on the side, because I'll be using this one to run our application. Building the app. Okay, so you can see there's a bunch of different directories that were scaffolded by Starport. In reality, you only need to pay attention to the X directory, which is where we're going to be modifying things and creating where our new types will be created, and also the view directory, which will host our front-end application. So let's wait for this to build. And if you haven't used Gitpod before, you might want to install some extensions. Let's say for Vue. So I have installed Vue. It just makes the formatting easier later on when you want to view a Vue file, or else it'll be just like unformatted text, which is not elegant at all. Okay, so our application is built. We can see two mnemonics that were created based off of this config.yaml file. So in the root directory of, let's say, POFE, you'll see that we have accounts, user1, user2, and the tokens they start out with. And these are their mnemonics, aka passwords. And you'll see that we have our Tendermint app running. So our blockchain is running at localhost 26657, running REST server at 1317, port 1317. And we can click on this, get started. Just open a new window. And we can see that we already have a UI that was generated. Right now, there's nothing because we didn't scaffold any types yet. All right, cool. So how do we create a claim? So what we want to do is we want to create a type called claim that lets people submit proofs, aka file hashes, to a blockchain. So let's do that. Starport type claim and proof string. Oh, so it turns out I'm not in the right directory. So cd POFE and just run that command again. Created a type claim, and your app should reload. Before I continue, does everyone see my screen okay? Do I need to like zoom in a bit? Are there any questions so far? Cool. So we scaffolded a type claim for our application. Let's go to our front end. And we can see that it's updated. So we have this new component called where we can submit a new claim, enter in a proof, and list claim items. And okay, so right now I'll show you what has actually updated on our backend. So you'll see inside the X directory, we have new handlers for creating claims. So we can create, delete, and set claims. Inside the x/pov/types folder, we have messages for creating, deleting, and setting claims that were automatically scaffolded. We created a type claim with creator, ID, and proof. What else? So we have our client. So we have CLI, and we have a CLI interface and a command line interface and a REST interface. So the first one I'll go through is a command line interface. So in the CLI, we will see query claim and txclaim.go. And inside the query claim.go file, we will see two functions called getCommand listClaim, which is here, and getCommand getClaim, which is here. So these are queries. They don't necessarily need to be handled in any way because they're just performing a query and they don't modify the blockchain at all. So these get added over here inside the query.go file inside the CLI folder. Next, you can look at txclaim.go. This essentially adds command line commands to create, set, and delete claims. So in reality, we're only going to be using create. We could also use delete, but we won't need to set claims. And these are also added in tx.go. So you can see the commands are added by pofedtxcmd.addCommand, flags.postCommands, and then these commands get added from this file. Something very similar happens in the REST interface, but instead of using a CLI, it's just REST endpoints and we register them. So we handle the functions, create claim handler, list claim handler, get claim handler, set claim handler, and delete claim handler. List and get claim handlers are in the queryclaim.go file. And txclaim.go has the create, set, and delete functions. And okay, so let's see. Jake, what text editor / IDE are you using? I am using Gitpod. So let me just show that again. github.com/tendermint/starport. So you want to go to this site first. In order to start your application in Gitpod, just go to the Starport repository on GitHub and click on Build a Blockchain with Starport in a web-based IDE. And this is going to open up a new window or open up the same window. You can create a fresh workspace. And it will initialize, and then you'll have this IDE. Okay, so to continue, let's see, we have our create claim handlers inside our REST client. All right, so essentially what happens is when someone sends a transaction, let's say anything inside the txclaim.go file or anything that needs to be actually recorded on the blockchain, we create a message. So let's say new message create claim, which is this file. And then this message gets passed to a handler, and the handler, let's say handler message create claim.go file, will emit an event which gets handled by the keeper. So inside the keeper file, you'll see that there's a file called claim.go where we create a claim, get claim, and this is kind of like a very raw interface to the keeper itself. So we won't necessarily be exposing the create and set, well, get, set, and delete functions from the keeper/claim.go file. but we'll also have list claim and get claim, which will be used by the querier handlers, which don't need to modify anything inside. It doesn't have to perform a transaction on the blockchain. So it's safe to expose these two functions. Okay, so that's just a brief overview of what the Starport type command has done. Okay, so now we can just look at our commands. Let's see, Pofed CLI. Let's see if that's there. All right, so you can see that Pofed CLI, which is our command line interface for our app, or already exists. You can do it. You can check this by typing in Pofed CLI, and you should see something similar to this output. And let's say we want to create a claim. So Pofed CLI px claim. Oh, no. So we want to use the Pofed module. And let's just look at our client/CLI/txclaim.go. So this is called create-claim. So that's the command we'll be using, create claim. And it takes a proof. Right now we don't have a proof. Let's just type in 1, 2, 3. Oh, so the creator can't be empty. So whenever you perform a transaction, you need to send it from a certain address. So let's just use user1. So user1 is stored in our keyring. So let's just enter that in. Oh, from user1. There we go. So you can see that this is the transaction that we'll be performing. Let's confirm it, type Y. And it's been sent. So we can query this transaction. So let's do Pofed CLI qtx q. So you can see that the output will look like this. And it'll give the information about the transaction that we just posted. You'll see some logs here. You'll see the raw log with the transaction hash, the height of the block, gas used, and details of the transaction and, well, the message that was sent. So you can see that we called create claim. It generated this UUID from this address. And the proof is just 1, 2, 3. So this address should also be the same as user1's address. Okay, so we have this transaction. Let's try to get this transaction. So again, we can do Pofed CLI Q for query and Pofed, which is our module, get claim, which should be inside our queryclaim.go file, and the ID, and we can see that it exists. Let's try the same with list claim, which should just be an array version of this. Yep, cool. Okay, so just to make things easier for users, we can already verify that this works. So instead of having someone manually submit, let's say, a hash of a file, let's say we just want them to pass the path to a file or something. So let's do that. So let's modify it in the CLI first. So inside Pofed client CLI txclaim.go, we have the create claim command. And we want to, let's say, implement some hashing functionality here. So we can see right now we take the first argument, arg0, and put in args proof, and then pass that into the new message create claim function. So let's start off by importing some packages. So we'll import crypto/SHA-256, encoding. util, no, io/io util. And we want to, instead of doing this straight away, let's do hasher 256.new s blank equals io util read file. So we're going, this is going to be a file path instead. So let's update that by passing the path to a file. So io util read file args 0 hasher dot write s, and instead of taking this string, because we want a hash of a file's content instead, we're going to do hex dot encode to string hasher sub no. Okay, so essentially what we did, we replaced args proof with these 4 lines. We imported these 3 packages and save. And it should build. Cool, so it builds again. Let's just look at our IDE. There should be nothing here again. Oh yeah, so in case you're using Gitpod, you can see which ports are open here. So that's also kind of helpful. Let's close this, close this, close this. And let's say we want to test this out now. Let's do Pofed CLI, tx create claim. Oh, nope. Pofed, our module, create claim. And let's say we want to prove that we made this blockchain. So the daemon that's actually running, so the binary for this is actually called Pofed. So actually, before I submit this, let me just do Pofed just to show that. So this is what is actually run by Starport. It's the app daemon for running this app. It's basically the name of your app followed by D, and then Starport runs a lot of these automatically, so you don't necessarily have to go through all the setup commands. In the past you did, but if you really want to dig into it and have like extremely custom things, or if you want to do things manually, you can always use Pofed to set up and start your application. So I'm just going to type in which Pofed. So we have this. This is the path to it inside Gitpod. And let's say I want to create a claim that I have this app daemon. So I want to prove that I made this app. So Pofed CLI tx Pofed create claim, which Pofed, and let's just say from user 1. And let's just say this is the proof for it. Let's confirm this. Yes. And the transaction should be posted. So let's just look at our front end. And it should be there. So the list of claim items will show up on your front end application as well. So you'll see the creator, ID, and proof for it. And as of now, we have a functioning blockchain, but we want to make some modifications. So right now, ID isn't really doing anything. We can use proof as the key. So what we're going to do is, and this will also kind of help you get an overview of like how to modify things after generating, let's say, a type using Starport. So inside Keeper, we have claim.go. And inside claim.go, we can see create claim. We'll take the context in a claim, And the key will be the claim prefix, which should be just claim dash or anything of that sort, something just to distinguish the claim from other things inside this module, and claim.id. But we don't want to use ID anymore, so let's just use proof instead. We also want to make sure that we're before I go on any further, this part is completely optional. This is just to clean up the application a bit. If you want to make sure things work 100%, just keep it as is. But let's say we want to use the proof as the key instead of ID, because that doesn't really do anything for us. So instead of claim.id, we'll be using proof. Essentially, we can just go here, claim.id, and or something.id dot proof. So let's just check in txclaim.go. We actually don't need this line. Well, let's keep that. So let's remove that. Even though we aren't necessarily using anything to set claims, we're not going to be using that. So let's delete handle claim. We want to replace this with proof. Replace this with proof. Handler message set claim. So we can move that, change this to proof. Claim.go. And let's see. Let's do another search. And let's just save this, save all of these files that we've modified. And if there's more things that need to be updated, it will show here. And another thing you should probably do is go to types, type claim, and delete this. And that should actually be one of the first steps, just to make sure that you're not using it anywhere else. Okay, so we can see some errors pop up, which is expected. New message set claim. So inside the new message set claim, which should be inside the types folder, we expect an ID, which we don't need anymore. So we can delete this, and delete this. Basically delete any instance where we're using ID. And this really helps if you want to, let's say, you not use ID at all and use something else that's generated, let's say a hash or something as the key. Let's go to txclaim.go. We don't need ID anymore. So let's remove that, and inside setClaim.go, instead of having an ID and a proof, we're just going to be using proof. We can change args proof to arg0. Let's see, setClaim.go, types claim, message.id is undefined. Okay, so did I not save something? Save. Okay, so now this builds. Let's try this, running this function again. POFE CLI TX, POFE create claim, Just click yes. Look at our front end. Let's refresh this. And you can see that the ID field is no longer there, which is good. And our app now works. We only have the creator and the proof. Okay, so now we have a functioning application where we can essentially just create claims. Let's also test out the delete claim functionality. So we have this proof. Oh, looks like we're still sending something in create claim. That. And we don't need UUID either. building, and it's running. Cool. So let's submit this transaction again. Yes, you can see that the message POFE/create claim value creator proof. And since we're using proof as the key now, you can verify this in here. Set claim, claim.proof, create claim, we're using claim.proof. You can do POFE CLI Q, POFE get claim, and then use the proof. Cool. Now let's try to do a transaction. POFE CLI, POFE, and delete claim. And we want to make sure it's from user 1 as well. So now that should be deleted. Let's verify this by running POFE CLI, Q, POFE, list claim, and it should be null, which is expected because we just deleted this claim. All right, great. So now this works from a command line standpoint, but we also have this front end interface that isn't that friendly. So let's refresh this. And essentially right now, you can take the hash of the claim, you can submit it here, and it will go to, it'll be submitted on the blockchain. So let me just give an overview of how to use this front end interface first, and we can start modifying it. So we actually don't need to do anything else inside the X directory. Now we're going to be focusing on our front end. So we already have these mnemonics generated for us. So let's copy one of them, sign in, click the sign in button, import, and we can see that that's our address, that's our balance. We have 1,000 tokens. We have an ability to send tokens to another address, and we can create a new claim. So optimally, someone should just be able to drag and drop a file into the UI and create a claim that way. So what we want to do is Tendermint Starport and go to the view file and just close all of these. So this is our application right now. So inside view/source/views, index.view, that is basically what you're seeing over here in the front end. So we want to create another component. Let's start by creating a new folder in the source directory called components. Let's create a file called dropzone.view. Do they have scaffolding? Do they have? So let's just create our view template. And so we have this template called dropzone, a component called dropzone. Now we want to import it into our main view. So let's do an import dropzone from components dropzone.view. And let's just add that to the list. And let's add it to the template, dropzone. So that should work. Let's check our front end. Refresh it, compiles, okay. Fine, but we don't see anything yet, so let's just add. Cool. Okay, cool. So we can confirm that our component is there, which is great. So now whenever we update our component, it will reflect on our front end application. All right, so let's add a bit more to our components structure, or the layout of our component. So we'll be using a few components from the Tendermint/view library, which is something that Tendermint developed to help with like Starport, and like it helps. So let's just take a look at index.view. So sp-signin SP bank balances, SP token send, SP typeform. These are all things that you currently see on our front end. So this is the sign-in, this is the balance, send tokens, and typeform. So we can reuse some of that functionality, such as like the buttons and the headers, just so that it matches the style of our app. So let's go back to our drop zone component. What we're going to be doing next is importing a header and a button from the Vue component library. So import h3 the button from Tendermint Vue, and we want to add it as components. So components SP h3 SP button, and let's just add them here for now. So SP h3 drop zone SP h3. Let's create a div for a drop zone. So let's just have div ID drop zone. We can change this a bit more later. And let's have our SP button, Starport button. Submit proof to blockchain. Okay, so let's take a look at our front end, and we have it. So you can't really see the drop zone, well, the div that we created aside from the header, but we see the header that we imported and the button where we can submit the proof to the blockchain. So let's continue modifying this a bit more. So let's just say let's add some data to our app first. So let's do data and return placeholder text, drag and drop a file here. What else? Hashed, the hash value. Keep that blank. Okay, that's enough. And let's actually add something for our drop zone div to make it a bit bigger. So let's go to our style, hashtag drop zone. Hashtag means ID. So let's just say we want it to have a height of 20 rem. And we want it to have a background color. Just give it a background color for now, just so that we can see, or blue, just so that we can see the zone. Oh, what's missing here? I'm missing a comma. So after components, comma, there we go. Semicolon, great, there we go. And now we can see our drop zone, cool. And let's actually just figure out what this color is. So let's inspect this. Let's inspect this. Let's see. Okay, so we'll match the color with the color of our buttons, which is RGB 247, 247, 247. If you're wondering how to do this, right-click on the button, inspect, and you should see something under styles. Just look at the background and copy that value here. And cool, we have it there. Right now we don't have, right now it looks connected to our button, so let's change that. Margin bottom to rem. Okay, cool. So now we have a drop zone. Let's add some text to it. So hashed or placeholder text And now we should have, okay, so well, that's not the best positioning for it. So let's change that a bit more. Line height, 20 rem. Let's do font size. And let's check the font family as well. So we want to, let's say, match, let's match this. Font family. So it should be this. Font family. Save, refresh. Okay, and now we need to align the text. Cool. So now we have a drop zone that looks like this. Minor, something really minor. I notice we don't have a radius, so we can ignore that for now. But let's just do border. Actually, no, let's just put it in. Border radius, 0.5 rem. And now we have a drop zone that looks like everything else on our homepage or application UI. So that's enough styling for now. So we don't need to play with that anymore. We can continue to update our divs. So now we want to be able to drag and drop something into our application, because usually when you drag and drop something into your app, it's going to open it in a new window, or it's going to open it in this window, and we don't want that. So to do that, we can, inside our div ID drop zone, we can enter in drop.prevent hash and drag over prevent. This prevents the default actions of what happens when you drag something over and drop it into our page. Drop.prevent will trigger a hash function, so we need to create a method for that. So let's create a function. So methods hash. And I'm guessing we would also want to have a submit method for submitting the proof to the blockchain. Okay, so let's just. So right now, these two functions don't really, these two functions don't do anything at all. But our application still works. No, we need a comma. So where's the comma? Let's just add another one here. Cool. So our UI builds, that's great. And hash actually takes an event as an argument because it needs to know. All right, so let's see. What else do we need to do? So we need to add some information about, let's say, what happens when we click our button. So let's do add click. So on click, we want to call this emit function. So loading. So loading is a property used by the SP button. So well, it'll tell you if you're allowed to. Well, it'll trigger a loading animation. So let's just do loading. And we'll create another variable called flight in our data. So flight false. What should we add? We should add something that lets us know if it's disabled. So hashed equals nothing or flight. Let's just do that. And okay, so we have everything there. Let's check the front end again. It's fine, cool. Now we can start implementing our methods. So let's start with hash. Okay, so in order to perform a SHA-256 hash, we'll just be using a third-party library called JS SHA-256. So inside your terminal window, you should still be in the POFE directory. What you want to do is change into the view directory, so cd view and npm install, save JS SHA-256. And it should install for you. Cool, it's there. So now we can import it. Let's try that. Import SHA-256 from JS SHA-256. And let's say when we hash a file, well, when we drop a file into the div that we just created, we want to get whatever items were dropped into it. So let's just do const files equals e.data transfer items. If no files, return, and just have a console.log first for the files. And let's try this. So just to see if it works. So I have some memes. Let's drag this here, drag and drop console. And we can see that, okay, so it doesn't open it into a new window, but it tells us that there has been something dropped here. So let's do that again. Da-da-da. Great, so now we can confirm that we can drag and drop something, and then we get actual information from that item that was dropped. So we can let's create a new reader to read the file. So const reader equals new file reader. Reader.onload. And let's just say it takes an event. And this dot hashed, let's update the hash value that we have here, will equal to SHA-256 of whatever file was uploaded. So ev target result. And so this is setting the function for what happens when the file is done being loaded. But then we also need to implement the functionality that actually reads the file. So reader dot read as array buffer files 0. Let's just take the first file and get as file. So let's check this out. So this is our hashing function. So whenever you drag and drop something into this zone, it should update this text with the hash of the file. So let's just do that. And there we go. We have the hash of the file in our drop zone, and we can submit it to the blockchain. But we actually can't submit it to the blockchain yet because we haven't implemented that functionality. So let's go back to our app and implement that. So we have our hash function. We don't need this console log anymore. Let's delete that. Reduce number of lines. And we have our submit function. So first we want to disable this button because it's being pressed. So this dot flex equals true. And then we want to dispatch something from our store, so in general, let's just go back to our front end application. Let's just say I submit a new claim 123 right here. You can see that it gets submitted. And it basically the Tendermint, well, basically our store should have functionality to submit and fetch values from the REST API that we have. So we can reuse this functionality so we don't have to implement it by ourselves. And that's what I'm going to be doing here. So this flight equals true. And let's make this an async function. So async, no, sorry, await this dot store dispatch. And we'll be dispatching Cosmos /entity submit. And we will be passing the value. So let's just take a look. Node modules, Tendermint, source, components, SP typeform. No, actually, no, we don't need that. We want to look at the store because that's where this is happening. So inside Cosmos JS, we have entity submit and entity fetch. So we want to get the type, which is the type of the thing we are submitting, and submit the body. So the body will essentially just be the proof that we're submitting to the claim. So type will be claim, body will be proof. Let's implement that here in our drop zone. So first we want to do type claim and body and proof will be this hashed. After that, should be done. And then we want to update the value that is shown in UI. So await this dot store dispatch Cosmos entity fetch type claim. And now we can unset the flight variable false. This dot hashed equals empty. We already set it. We don't need it anymore. It should reset. And then let's see what else. That should be it. Okay, so let's try that now. So this should. So now when we drag and drop a file here, it should show up here as well. So let's try that. Submit proof to blockchain. Submitted. Submitted. And I spelled entity submit wrong, so nothing happened. Let's change that. Entity submit. Let's try that one more time. Submitting the proof. And you can see that it shows up here. And that, my friends, is a completed application. So we have implemented, just to go over everything again, we have implemented the functionality on our blockchain to accept the hash of a file as a claim, and it will store it there inside a certain block. And whenever you want, you can take that transaction hash and just share it with people to prove that you made this transaction. And we have also implemented a command line interface, which you can use to interact with your files, with a command line interface where you can select a file that you have and perform a hash of it and then submit that hash to the blockchain. And we have also implemented a UI using a few components from the Tendermint/Vue component library that helps us drag and drop a file and submit the proof to the blockchain. And that is all. I hope you guys enjoyed this workshop. Does anyone have any questions? Don't see anything in the chat yet. Okay, so it seems like there are no questions at the moment. I really look forward to seeing what everyone is going to build in this hackathon. And just a brief shout out, we are planning on having a fellowship. So if you do work hard on your blockchain and if you submit something, we will be reviewing, we are going to review all the projects, and we may select a few to take part in this future fellowship. More details will be released later on, but I think it's a good idea to let you guys know about that now. No problem. Hope you enjoyed the workshop. Okay, and it's a wrap. Thanks everyone for attending.